Good morning. It's June 25th, and this is your daily brief in science. Here's everything you need to know. The Samuel Oschin Air and Space Center opens to the public on November 13th, with Space Shuttle Endeavour mounted vertically as the centerpiece in the Samuel Oschin Shuttle Gallery. The exhibit emphasizes education and inspiration, offering interactive elements such as a gantry-style elevator ascent, a 45-foot descent slide, and a replica flight deck with cockpit controls for visitors to explore. The complex includes multiple galleries, including the Korean Air Aviation Gallery and the Kent Kresa Space Gallery, housing more than 25 aircraft and spacecraft artifacts, with installation ongoing ahead of the opening. The project took 4 years to complete and achieved a stacking of the shuttle that engineers once considered impractical, a milestone described as the go-for-stack process that attached Endeavour to its boosters and external tank. Led by Dennis R. Jenkins, the project involved ZGF architects, Arup engineers, mat construction, and evidence design for exhibits, with donors including the Samuel Oschin Family Foundation, Korean Air, and the Kresa Foundation, contributing about $410 million toward a $450 million goal. Governor Gavin Newsom praised the expansion for advancing science education and innovation for future generations, while NASA contributed $65 million to obtain the external tank ET-94 after lengthy negotiations. Linda Oschin, widow of Samuel Oschin, called the display a meaningful tribute to her husband and a foundation gift that preserves his memory. The opening highlights California's aerospace and defense investments and job-creating expansions, alongside CalCompete's tax credits and multiple company expansions in the state. Endeavour's history and NASA centers in California are noted, with attention to the shuttle's missions and the state's leadership in NASA-related spending. The reveal marks the culmination of a multi-year project that began with groundbreaking in year 2022 and concluded with the building's completion in spring 2026. A strongest organic signal yet from Jezero crater has emerged, as the Perseverance rover's Sherlock instrument detected abundant macromolecular carbon in Bright Angel mudstones along Neretva Vallis, hinting at potential biosignature clues but stopping short of proof, since such carbon can form through non-biological processes. Sherlock mapped organic matter across the mudstones, recording hundreds of detections and marking the strongest organic signal identified in Jezero to date. The context is surprising given Jezero's history of water, yet the widespread carbon signals in these Bright Angel rocks raise the possibility of preserved or recently exposed material that could bear information about past habitability. The team notes that the macromolecular carbon, MMC, could be recent or protected by minerals offering photoprotection, so origin remains uncertain. Potential sources for MMC include delivery by interplanetary dust or meteorites, in situ abiotic chemistry from volcanic or hydrothermal processes, or biological synthesis, though no confirmation of life is claimed. Interpretations of the carbon's origin remain open and will depend on further study and analysis. Researchers emphasize that life on Mars remains unresolved and hinges on future analysis of cached samples returned to Earth. While the finding represents one of the strongest potential biosignatures to date, it does not confirm life and highlights the importance of Earth-based sample return for a definitive determination. The results were published in Science Advances on June 24, 2026. Previously observed leopard spots or poppy seed patterns in the rocks had suggested ancient microbial activity, but non-biological explanations remain possible, and the signal includes minerals like vivianite and greigite that hint at electron transfer between sediment and organic matter. Organic carbon is interwoven with silicate minerals and later formed carbonates and sulfates, suggesting two potential emplacement events without revealing the ultimate origin. Ionis Pharmaceuticals gains FDA approval for TRYNGOLZA olezarsen as an adjunct to diet to reduce triglycerides and pancreatitis risk in adults with severe hypertriglyceridemia. This makes TRYNGOLZA the first and only approved therapy for both TG reduction and pancreatitis risk reduction in this patient group, delivered via a once-monthly auto-injector. Phase 3, CORE and CORE. 2 trials show up to roughly 72% triglyceride reduction and up to 91% fewer pancreatitis events. Ionis highlights that this expands their existing approvals for related conditions and positions. TRYNGOLZA as a key offering for adults with TG at or above 500 mg per deciliter. The U.S. launch is planned for July, with 50 mg and 80 mg monthly doses approved for both SHTG and familial chylomicronemia syndrome. Market Context notes a price-to-sales ratio around 12.5 and a patient stock price history from the high 30s to mid-80s over the last year. Analysts and investors are weighing the FDA decision alongside potential implications for Ionis and its partners, including leadership updates and collaborations tied to Spinraza and Qalsody. Ionis's board appointment of Ludwig Hansen and recent sentiment from Biogen, GlaxoSmithKline, and Oppenheimer shape the pace of expectations as 2026 revenue guidance is raised to about $875 to $900 million. The company lists a GF score of 69 out of 100, signaling moderate overall performance with growth strengths but financial and profitability weaknesses. Safety notes indicate hypersensitivity and allergic reactions have been reported, requiring discontinuation and urgent care if symptoms occur. Ionis remains a leader in antisense technology with a broad pipeline across cardiovascular, metabolic, neurological, and rare diseases, and a strategy centered on collaborations. In short, TRYNGOLZA marks a milestone for SHTG treatment, with a high-impact Phase 3 data backdrop and mixed near-term equity implications as the market digests the approval and its potential trajectory. Two planets almost the size of Jupiter, but with densities lighter than cotton candy, have been identified around a sun-like star in the Valens constellation, about 1,110 light-years away. The discovery comes from NASA's TESS mission, with transit observations spanning roughly a decade and extended by long baseline data over about 1,122 days from high Earth orbit. These ultra-low-density giants are among the largest known planets by size to have such low densities, measured at about 0.022 and 0.027 ounces per cubic inch, while retaining Jupiter-scale radii. Oxford researchers describe the planets as primarily hydrogen and helium with cloudy atmospheres that may appear white or blue. Analyses indicate the densities come from orbital data, supporting a fluffy, gas-dominated nature rather than solid surfaces. The findings, published in monthly notices of the Royal Astronomical Society, add important insight into planet formation and the diversity of planetary systems, prompting questions about how such ultra-low-density giants form and evolve. The discovery leverages transit data from TESS and is set to be further explored with the James Webb Space Telescope to better understand their atmosphere and chemistry. Researchers aim to study the system's dynamics and atmospheric composition to unravel their formation and migration histories, including whether thick hydrogen-helium envelopes formed farther out in colder regions of protoplanetary disks. One theory suggests superpuffs could originate with extended envelopes in distant regions, but exact formation remains uncertain. The work is part of a broader effort to chart the variety of planetary systems, with follow-up observations expected to refine measurements and test models of giant planet formation. Further Webb observations are anticipated to confirm the planet's chemistry and atmospheric properties, helping to clarify how these puffiest known giants fit into current theories. A landmark finding from a South African cave study raises questions about Homo naledi's social behavior by analyzing tooth enamel. Researchers examined the Dinaledi chamber and report an apparent absence of amylogenin Y, a protein linked to the Y chromosome, which could indicate all female individuals in the burial assemblage. The team presents two main interpretations. Either every individual buried there was female, or there is a deletion of the amyli gene in males, a scenario that would be unlikely to occur across many individuals. They emphasize that more data and replication are needed to determine if this pattern holds across additional samples and to explore its evolutionary and behavioral implications. Some researchers view the result as potentially supporting intentional burial, while others caution that the finding could reflect sampling bias, preservation, or non-behavioral factors. Alternative explanations include skewed sex representation from demographic factors or preservation bias, underscoring the need for further evidence before firm conclusions about social structure or rituals. Context includes the 2013 Rising Star cave discovery near Johannesburg. and ongoing debates about funerary practices in Homo naledi, with researchers offering cautious or alternative interpretations. Some scientists warn that amylogenin analysis could yield false positives or be impacted by degradation, necessitating additional verification. Beyond this single finding, the research demonstrates enamel protein analysis as a tool for resolving sex and lineage when DNA is not preserved, potentially informing assessments of other famous sites. The discussion touches on broader implications for Homo naledi behavior, including possible sex-biased assemblages, cave access issues, and insights into ecological and social structure. Published in Cell, the study contributes to the debate about deliberate burial by Homo naledi and calls for further evidence to clarify the site's social and cultural implications. Researchers consider the result unlikely to arise by chance and evaluate alternative explanations like amyloid degradation or gene deletion, deeming them insufficient without more data. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.